2.8 higher derivative. So we've just been doing y prime. Well, you can do y double prime has 2 ticks. Y triple prime has 3 ticks. So in notation, that would be double prime is second derivative. That means you have to do it twice. Okay. This is the Lebanese way of just a way of putting it, of doing double derivative. Again, we don't have to really use that very much in this case, but it comes from derivative of the derivative. Okay, so you can kind of see d over dy, that's d squared y, dx dx, their whole thing is essentially squared. Okay, but again, it's not just a notation there. We're not going to need to use that as much. Okay. Just the idea that I think the only thing I want you to get from this page, there is a second derivative or there can be a third derivative. Okay, and they do help find things. Okay. All right. So this means I want to find the double derivative of x to the 6th. Give you an easy one to start. Y prime is 6x to the 5th. Right? Y double prime, 30x to the 4th. You found your first second derivative. What's that? Yeah, you just do it again. That's all second derivative means. It's just, of course, gives you the baby step, but there's going to be the second one. You're like, oh, I don't want to do this one. The first one seemed okay. Yeah. Yeah. The double derivative, yeah, it's going to give you, so when we go to our applied stuff, the first one's the equation of the tangent slope. The second one will be the equation of how the tangent slope changes. And so like in terms of, we're going to get into it in terms of velocity and acceleration. I think, I'll have to look, but I think the second derivative is acceleration. First derivative is velocity. Okay, any other questions? Okay, so let's move on. You weren't challenged there. So this one, find the second derivative. You guys go ahead and try it. See if you can get this one, and then we'll pick it up from there. I'll pause the video here. All right, so then working through this, the first one. Okay, or like I was telling Joe, so you can write this, no problem with exponents still, which is fine, which might be easier in this case, just because we're taking the derivative again. So it'd be 1/2 x to negative 1/2. So then your second derivative would be 10 minus 1/4 x to the 3/2, or negative 3/2. Okay, any questions, concerns with that one? I'd say in terms of writing it in radicals or exponents, I don't really care too much, other than don't write things as a final product with negative exponents. So if you, like here, if you write that as negative 3/2, I would prefer that you put it on the bottom, so that you know it's on the bottom, because what that helps you with is it helps you with your domain and range. Because if you know it's at the bottom, you know you have some restrictions. It can't be 0, right? So just things like that are pretty important. Okay. So we're going to do f double prime of 1. So it wants me to find the double derivative and then plug 1 in. That's what that notation means. So I'm finding the second derivative, and then I'm plugging 1 in. Let's see if you can try this one. Yes, it is chain rule. 340 is correct, so good job for those of you guys who got 340. You will get 340, you plug it in. The biggest thing in this is people think that, okay, you have to do chain rule. So you f prime, you're going to get 10, 2 minus x squared, 2x. Now the problem that yields is that you're not going to like is it's now create a product rule for you. Yep, power to 9. Sorry, thank you. Okay, so that just makes things complicated in the sense we have to do product rule, which we don't like. Okay, so now we have to go, okay, double prime. So really it's 20x. We can write that as, yes. So negative 20x, thank you. Like that, thanks. Yeah, okay, so then we have our product rule. So first, derivative of the second. Plus second, derivative of the first, which would just be negative 20. I'm out of room here, but, well, maybe not. Like that. So I simplify everything here. Negative 180, so positive 360, x squared. Does that look good? So let's just test it here. So if I put a 1 in here, that's 1. 1 to the 8th is 1. 1, so that's my 360. 2 minus 1 is 1. 1 to the 9th is 1. Minus 20, 340. Okay. All right, so I went right to the example 4, but to answer kind of Kia's question, in the book it says first derivative, I'll just use the equation of the slope of the tangent. First derivative. Second derivative is the rate of change of the slope of the tangent. And then the next derivative is the rate of change of that, the rate of change of that. So it's continually just taking the rate of change of the previous one. So that makes sense. So this one, they want us to practice doing the fifth derivative. So number 1, they give you something easy at least. Two. 3. 4. And 5. Or maybe use a slash here. 0. We have one more example. Everything good? All right. All right, last one. All right, so we come back full circle. We're going to do implicit differentiation with a second derivative. Okay, so we're going to find y double prime. So we got to just first things first, we got to start with doing the derivative of that normally. So we do the derivative normally. So that would be y prime, or excuse me, not y prime because it's not a function of y, be 3x squared plus 3y squared y prime equals 0. So I need to solve for y prime, right? That's the point. So I minus the 3x squared. Divide by 3y squared. So y prime is x squared negative over y squared. Now, what don't we like about this? Yeah, we have to use an implicit with quotient. Well, we have a quotient rule. So we have to do low d high minus high d low all over. Yeah, so low d high. So we're doing quotient rule here. But remember, you're doing it with implicit. So anytime you take a derivative of something with a y, you have to put a y prime on it. So low, right? So it's going to be y squared d high negative 2x. I'll just bracket that. Minus high negative x squared. D low is 2y y prime. What does it say, Nikita? It's a minus. Yeah, I was putting it there for a second. Do you see that? And then it's all over low squared, which is y to the 4th. All right. Okay, so if we just kind of rewrite this, clean it up a little bit, it's going to be negative 2xy squared plus 2, so it'd be plus 2x squared y prime, all over y4. So this is where you're really going to be like, what? So what do we do now? So Soxy said exactly what I was hoping you'd say. She said get y prime. But what are we going for? Y double prime. So solving for y prime is not effective. This is y double prime. But we don't know. Do we know what y prime is? Ah, we know what y prime is. Yeah, you put it in there. Okay, because now we know what that value is. It's not unknown, right? Just keep it clean over there. Yeah, maybe. Why did I write prime again? See, I'm all distracted. Yeah, that's true. I'll start blaming everything on Emily now. All right, so let's go back to this here. All right, so it's... All right. Okay. And so then what you'll notice is this is really x to the 4th, and then over y, because that's how it's going to simplify. It's a y over a y2. So it will be over y, which what we'll do now to get them together. All right, so let me rewrite this on the next page. I need some more room here. I'm just rewriting what I already had. So it's going to be it was a negative negative, wasn't it? This one?
Yeah. But like then was it times by a negative x squared, like y prime is negative x squared?
Oh, yeah, it's going to come back. Let's see here. Yep, that should be. Minus a minus. So you're saying it's a, yeah, you're saying it's a minus. Hold on, let's see here. Yeah, it is a minus. I think I just actually pull a negative out. That's a plus now when it should be a minus. Yeah, it's a minus. Okay, so that's good. All right, so this is a minus here because of the, man, the eraser's killing me. Minus. Yeah, it's a y cubed. Oh, nope, I'm the line ahead. All right, so we're there. It's minus 2yx4 over y2. That's right, all over y4, right? Okay. Yes. And then it's a, yeah. Okay, so how I got to here? Okay, so from here, we plugged in this, right? So we just multiplied that in. X2 times x2 is x4. The y over y2 is still there. We're going to do that in a second. Okay, and then this was a negative, made a positive, but then this negative switched it back to negative, which is Chris talking about, and then this was the same. Okay? All right, so now the last thing I'll do here real quick is I'm going to do this. You're going to see where the okay. So what happens is we want to get these to be a common denominator, so we put them together. So to do that, I'm going to make this over y, which means I times it to the y. That's where the y cubed comes from. So I'm just going to put this over y, and then I'm going to add, I'm going to make this another y to make it y3. So then it'd be this. So I got a common denominator. This was over y. I want to make this over y as well. So I times y in.
So then shouldn't it be y cubed?
Yep. I said it. Y5 is going to be y5. Gosh.
Yeah. But it's not y5?
It's going to be. That's what I was trying to sell next. Okay, so we're here. Remember, this goes there. Y4 and a y1 is a y5. And that is where we are getting to very slowly. That is your double derivative. You can pull out a negative 2x again if you'd like. And on this question, it said, nope, that's, did it ask us to plug anything in? What did it ask us to plug in? 5? Nope, it just said find double prime. That is double prime. Oh, okay. I'll show you what they did. Here's what they did, though. This is what you're going to have to get good at, so I'm going to show it to you. Last thing, sorry. Negative 2x comes out of both of them. That gives me y cubed plus x cubed. Right? These both have negative 2x. Did everybody see that? The reason that's helpful is because we actually know what this is. So now we can make that a 5. Oh, yeah. It's the fun part. Oh, I know what that is. So it's negative, the actual double derivative fully simplified is negative 10x over y to the 5th. Yeah, that is clever. Yep. Let me finish this. I'm going to turn the video off. Your tests are like 10 marks.